carbon is reacting with oxygen, somebody may say fluorine is reacting with this. There has to be a unified language in which we speak, okay? A codified language, and the codified language should be uniform, so that what I use is what you use, and slowly what I use, what you use should be globally that what we use, okay? So chemistry has been into practice from say 16th century onwards, and after that, as then when discoveries and inventions were made, people were naming things. But back from 1970s, we had a body established. ये तो पहले लिख लो. We have a body established, and they said nothing doing everything to your choice and fantasies. You need to obey everything as per IUPAC. IUPAC stands for International Union of Pure and Applied Chemistry. Applied chemistry. Unlike physics, chemistry is very, very vast. So if you do not follow a code, it will be very difficult for you to spread your knowledge to somebody, or you to accept knowledge that somebody already has. So what we follow is always known as International Union of Pure and Applied Chemistry, and they'll have rules for naming compounds, organic chemistry, everything. They're like a body, okay? And they set the rules how things have to happen. So let's go ahead. So basically what we study in chemistry is all about, we will be studying all about chemical reactions, okay? And if you look specifically at chemical reaction, what is happening? We say new substances are formed with new properties. This is also known to us. New substances get formed with new properties. In order to achieve this particular statement, we have to have, for this to happen, we should have a chemical reaction. And in a chemical reaction, if you see further, who all are taking part, we say atoms chemically combine to give you what is known as molecules. Now at this stage, it can be also that an atom of oxygen combines with an atom of oxygen to give you a molecule of oxygen, but I'll go with a little bit more complex. I'm trying to say atoms of different elements, right? They chemically combine to give you a molecule of a compound. So if you look at this statement, the most elemental form of an element would be an atom, and the most elemental form of a compound would be molecule. So atoms chemically combine to form molecules. Now this, in theory, we can go on speaking, and in lectures we can go on explaining people, but you need to have a concise language how to show these reactions. That concise language is chemical equation, which we will come in the latter part of the chapter. But before that, question arises, how do you represent these? How to represent an atom and how to represent a molecule. ठीक है बच्चा, समझ में आया? इस कहानी को लिखने के लिए, to write this story, you need to have some codified equations and languages, which is uniformly same, accepted worldwide. To write that code, you should first understand what are the codes. So what are the codes? Briefly, with the starting basic fundamental block, we'll say the codes that are needed to understand an atom or to represent an atom and a molecule. Are we set now? Okay. So can I rub this much? This much story is understood, right? Very good. So the next stage that we come into and we will speak about is how do you represent an atom and how do you represent a molecule? Okay. An atom is always represented. Now, an atom is something that you always see in a periodic table. Sorry, children. An atom is something that we are seeing in the periodic table. And in the periodic table, what do you see? You see atoms. We see atoms, and the atoms are represented by their symbols. First, understand the word symbols. Underline the word symbols. Symbols are used to denote atoms. And the symbols are usually English alphabets, English alphabets, maybe 1 or 2, in which the first one is uppercase, followed by a lowercase, and this English alphabets are either derived from the English or the Latin name. The English or the Latin name. Okay? Let's take some examples. Molecules baad mein karenge. Let's take some examples. Now, how these naming came, that's basically in the order that they were discovered. Like oxygen was discovered long back. So when oxygen got discovered, so oxygen was straight away allotted the symbol O. But after oxygen, we got some more elements also. They no more can be represented by O. So how are they represented? They are represented by O followed by the next letter in their name. What name? Either English name or Latin name. Okay? For example, let's say I have something called copper. I have something called copper. I have something called carbon, and I have something called calcium. Now, carbon was the first to be known, so carbon got the letter C. Afterwards came calcium, so calcium got Ca. If you look at cadmium got Cd. If you look at cesium, it got Cs. However, if you look at copper is Cu because it comes from the Latin name cuprum. Clear? Similarly, let's say sodium. Sodium got the name Na because sodium's Latin name is natrium. So, sir, why did you not give N to sodium? Arey, nitrogen पहले discover हो गया था रे भाई. So nitrogen took the N. Sodium got Na. Right? Potassium was first in the K series, came from the Latin name called Kalium. However, something like krypton was discovered later. So krypton could not get the name K. K is already taken. So krypton takes Kr. Right. The most important thing, whether you have noticed or not, I don't know. That is what you should see. Symbols will never have numbers with them. Always remember, symbols can never have numbers with them. Because you are an atom. An atom means only one. It cannot have numbers associated with them. Okay? It will never have numbers. You look at the periodic table never has anyone with numbers associated. Symbol samajh mein aaya? So symbols are used to denote atoms. So what happens in a reaction? Atoms are a part of the reactants. These atoms chemically combine to form what? Molecules. So molecules are the products. Molecules are the part of product. So abhi hame molecule ko represent karna bhi seekhna aana chahiye. Come, let's start representing. Is there any questions on representing atom? Anyone has any doubt? Okay, no doubt. Right, fine. Atoms are always denoted by English alphabet, capital letter followed by small letter. Sometimes only capital letter. If there are two letters, the next one should be small, and they are the sequence of letters as appearing in the English or as appearing in the Latin name. Pakka? Chale aage? Chaliye. Aa jao. Now we talk about how you represent molecules. Now, when you represent molecules, now molecules can be representing element and molecules can also be representing compound. Have clarity on this. For example, CO2 is a molecule of a compound, O2 is a molecule of an element. Okay? Molecules are always represented by chemical formula. Chemical formula. So what does a chemical formula comprise of? A chemical formula comprises of two things. Number one, it will have symbols of constituent elements, or rather, should I write symbols of constituent atoms? And number two, so this is the alpha part. And number two, it will have their respective count So this is the numeric part. So a a chemical formula will always be alphanumeric, children. Alpha stands for the symbols of the constituent element, and numeric stands. In fact, this thing you'll have already studied. You said, right, in your test you got something like MgSO4 to write what is the molecular mass, right? So you exactly went through this. So I'm giving that example itself. Say suppose we'll have two type of examples. I'm taking one more complex example. MgSO4. MgSO4 stands for magnesium sulfate. So if I look at the constituent elements, I have got magnesium, I have got sulfur, and I have got oxygen. And if I look at their respective count, magnesium is 1, sulfur is 1, and oxygen is how much, beta? 4. So we write it as MgSO4. Now remember one more thing. When you are writing chemical formula, these numbers and count ultimately should also be in the simplest ratio. Barring some exceptions are also there. Okay, simplest ratio when we say, not exactly every time. In organic chemistry, we'll see them in simplest ratio. But in some other things, we may not see them in simplest ratio. For example, and here there's a conflict. The book will not speak anything about that, but keep this in mind. Just understand. Say, for example, there is a compound called, say carbon dioxide. We will never write it as C2O4. We don't write it as C2O4. Unless and until there is a bonding difference, the way the bonding is happening, there's a bonding difference, we will not write C2O4. Now the contradiction comes. When you have ear infection, there's a liquid that is poured in your ear called hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide's formula is H2O2. Now you may ask me, sir, why did they not bring it into simplest terms? Simplest term should have been HO. Why did they not bring it in terms of HO? No, there's a bonding difference. There's a bonding difference. We'll study that. Then organic compounds like say there's a compound called ethane, C2H6. Sir, why did they not write it as CH3? CH3 is not the structure. When we go for organic compounds and all, more than the chemical formula, the structural formula becomes very important. In inorganic, the chemical formula is more important. In organic chemistry, when we'll go, the structural formula is more important, because with the same chemical formula, you can have two different type of structures. If I try to explain now, maybe it will be a little bit of overhead transmission for you, but every time simplest ratio does not happen. In organic chemistry, there is nothing called simplest. In fact, in organic chemistry, nobody is interested in this formula of yours. Rather, you know what people will be interested from you? People will be interested that you write it like this, CH3. Sorry. Either you write it CH3, or you write it H3CCH3. People will be interested in this one. This is more important. वो C2H6 इसमें इतना important नहीं रहता है. But in inorganic, C2H6 is more important. So when we see, well, this is little, whatever I have written, this is little bit dicey, but you will understand it as and when the chapter progresses. As for you right now, any chemical formula of any compound that you see is always expressed in lowest terms in inorganic chemistry, like acids, salts, MgSO4. You don't see Mg2S2SO8. ऐसा नहीं रहता है. ठीक है? Clear? Now comes, we'll go by a textbook. Now comes a section called naming. So can you decode these also? Like always I give this example, Al2SO4 whole 3. So Al2SO4 whole 3 stands for aluminum sulfate. We will see that. And it shows 3 elements out here, aluminum, sulfur, and oxygen. And the counts are very important. 2 belongs to aluminum. 3 is overall for both S and O. So S is 1 inside. So 1 multiplied by 3, S gets 3, and O is 12. Remember that. Okay. Later on, you'll also find water of crystallization associated with it. 24 molecules of water of crystallization also associated. So finally we will write oxygen. We have to add these oxygens also. ठीक है, वो धीरे धीरे आएगा, देखेंगे. चलिए, अब next part is how do you name? How do we name? Now from here your knowledge and your interest will be required, because we won't be able to give you a shoe that a perfect formula does not happen. So come on, write with me certain things called. Let's first understand what is an ion. Otherwise, you will not understand this section. Ion, right? So an ion is an intermediate entity. Intermediate entity. Sir, is an ion stable? No, not at all. An ion is not stable. An intermediate entity that is formed after an atom either loses or gains what? Electron. Either loses or gains electron. Understood? So let's have an atom A. And atom A right now, I don't know what is the count of protons and electrons in this atom. Try and understand, okay? I don't know what is the count of protons and electrons in this atom. I don't know. But as long as when I write it A, what is the oxidation state out here? The oxidation number is 0, which states the overall charge is 0, means it states that it is a neutral stable atom. समझ में आया? Neutral stable matlab the overall sum of positive is equal to the overall sum of negative. Where? Inside this atom. This just stands for sigma. Do you know this sign? This stands for sigma. Sigma. Okay. It is like this. Actually, in print, it will be something like this. This is sigma. A sigma stands for summation. Summation means some sort of a total. So we write it like this. And this is capital sigma. There is a small sigma also. We use this in statistics. Summation. Summation means when we study statistics, not for mean, when we study statistics, we use this symbol. Sigma means sum. So if I say sigma n means sum of all the natural numbers from 1 to n, right? So I have used the word what? Sigma positive means sum of all the positives is equal to sum of all the negatives. Because right now I'm showing this as A. Got it? Now A can, in this, there are two type of things can happen with A. Generalized, I'm saying. A can accept n number of electrons, right? In that case, what happens? There will be an excess of n electrons on it. So A becomes an ion with A n minus. Suppose there were 5 electrons and 5 protons, and it ate 2 extra electrons. So 2 extra electrons will come up as negative charge. Is it clear? Such type of an ion is known as anion. Again, I'm just saying generic. A can lose electrons. Beta lose electrons में हम कभी भी minus यहाँ नहीं दिखाते हैं. Lose electrons में हम दिखाते हैं A lost how many electrons? N electrons. So A became what? N positive. In such case, we call this as cation. This is how we write cation, so that you don't confuse which is cation and which is anion. ये clear हो जाओ अभी से, right? Clear? What is an ion? An ion can be positive as well as negative. A positive ion is formed when an atom loses electron. A negative ion forms when an atom gains electron. ठीक है? आ जाओ. Why I taught you ion? Now the importance comes from the periodic table. Very happy, Shastra. The way you have opened that periodic table, I hope that's a periodic table only, right? Yes, that is very much required. अब देखो how we do this. Suppose this is my periodic table, rough periodic table, okay? So I'll go by the Cambridge naming. I have got group 1, group 2, and then there is a transition block, and this is group 3, group 4, 5, 6, 7, and 8, right? Group 1, group 2, then 3, 4, 5, 6, 7, and this is 8. If you go by international system, this is group 1, group 2, group 13, 14, 15, 16, 17, 18. We are versed with this. आप ऐसे सीख लो, ठीक है? 1, 2 और 3, 1, 2 और 3 आप लिख लो अभी. इसके बाद और now you should know it. They will always be electropositive valency. What do you mean by electropositive valency? Sir, in 1, 2 and 3, I am going to always lose electrons, right? Then I should also understand what is my valency. So for periods 1, this is as per the Cambridge formula, 1, 2 and 3, my valency will be always equal to my group number. Very easy. Whereas in CBSE, we will go and say 13 minus group number minus 10. But for you, it is group number. If that be the case, write down in group 1, group 2, and group 3. Okay, group 1, group 2. Group 1, what would be my valency equal to beta? 1. What will be my valency here? 2. And what will be my valency here? Sir, 3. But remember, all these are electropositive. Which means, what did I define valency as in the other day? The number of atoms number of electrons that an atom can gain, lose, or share. So valency 1 means it has the hunger for 1. What type of hunger? Hunger to give away. Got it? That's why electropositive. So all the group 1, if the group 1 elements are represented by E1, say generic, I'm saying generic, the E1s will always form E1 plus. And what are the E1s? Hydrogen. Hydrogen we never consider as group 1. Hydrogen does not have a place. Lithium, sodium, potassium, cesium, rubidium, cesium, francium. Helena ki rab se faryad, ruby se friendship, whatever you say. So they will always form plus. Do you understand this? So this means lithium will always be Li plus, sodium will be Na plus, potassium will be K plus. You should know only 1 to 20 now. So I'm writing all your 1 to 20s. Have you this beta? ये एकदम दिमाग में बैठ जाना चाहिए. Whether it is there in Cambridge book or what language, once you understand this, your life becomes absolutely easy. Okay. So group 2 wale elements, suppose they are represented generic by E2, they will all be 2 plus. Who are those? Sir, beryllium 2 plus, magnesium 2 plus, calcium 2 plus. In your case, only these things are required. Nothing more than that. If the elements in group 3 are represented as E3, so they will become E3 plus. Sir, boron 3 plus, aluminium 3 plus. Nidhi madam, just see whether anything that you have not understood. We feel absolutely free. These are very simple things, but sometimes they get jumbled. So first of all, you should know, you should always, children, have a periodic table printed in front of you. Otherwise, what I'm talking will not make sense at all. And then you will own that periodic table. No matter, bring another, ek din pencil lao, laake thoda sa scribble kar lo. Again, bring a fresh periodic table. Slowly, what will happen? Ye ekdam baith jayega ye dimag mein. Right? Group 1, group 2, and group 3. And if you further want it, so it is hydrogen, though they show here, I'll not talk about hydrogen. Li, na, he, ruby, say, friendship. And you are interested in only these 3. यहाँ पे क्या है? Beryllium, magnesium, calcium. ये हमने लिख लिया आपके लिए. 3 में कौन कौन आएगा? Boron and aluminium. Because you are a grade 9 student. You are not supposed to know anything more than 20. Calcium is 20. Chale aage, right? Then we come to group 4. Group 4, the valency will also be 4. The valency will be 4. Sir, why did you not include it here? I did not include it here because the valency won't be electropositive. An atom cannot lose 4 electrons. The maximum you can lose is how much, beta? 3. The maximum you can gain completely is how much? 3. And the maximum you can share is 4. Please understand. In share, 4 is allowed. Gain 3, lose 3. So this is 4. They usually all will be doing sharing. Sharing hoga. और इसका covalent bonding बनने के chances maximum है. In fact, carbon right? So for us, we are not supposed to know any electropositive or electronegative. Valency is 4. So right here I would write that I have got carbon and I have got silicon. So all will be having a valency of 4. They have a valency of 4 at your level. Take. We then go to, can I rub this question? Okay, I'll write it here. We then go for valency for group 5, 6, 7 and group 8. 5, 6, 7, 8. Right. Here, the formula of valency is 8 minus group number. 8 minus group number. Got it? So for group 5, the valency would be 3. Here the valency would be 8 minus 6, that is 2. 8 minus 7, 1, 0. That's why this is the inert gas. Iska koi valency hai nahi. This particular family has no sort of H at all, either to lose or share, extremely stable. But mind you, all these valencies will be electronegative, which means that if I have an element in group number 5, and the elements I would have here are nitrogen, it will be 3 minus, phosphorus 3 minus. Then here I'll have oxygen 2 minus. Hey Nidhi, now you understand why oxygen is 2 minus. Now story becomes clear. And I would have sulfur 2 minus. Then number 7. 7, like the name of this group, this is known as the halogen family. Halogen family. Okay, for naam jaan lo. Group 1 is known as alkali metals. And group 2 is known as alkali earth metals. Means these are those alkali metals which are found in the earth. Alkali earth metals. And this side is all usually metals. This is metals. And all these will be my non-metals. However, these are very dangerous people. These will form usually metalloids. Na is side ka, na us side ka. And metalloid is not exactly group 4. Huh? Look at here. Metalloid will be slowly doing staircasing as you go higher classes. You will find silicon, phosphorus, germanium. These are all metalloids. Neither metal nor non-metal. Okay. So यहाँ पे क्या आएगा? Sulfur minus. Then group 7 is known as the halogen family. I'll have fluorine, bromine, chlorine, iodine. For you, fluorine, bromine, chlorine is more than enough. Group 8 is all satisfied. Helium, neon, argon, krypton, xenon, and radon. All satisfied. Okay. So what did we study before this? We studied ions. So in the case of ions, I would not rub this, children. So don't get confused. I would not rub this. So when you study ions, ions are studied under two heads known as simple and compound. You are calling it compound. We used to call it polyatomic. Same thing. Polyatomic. Let's first understand simple. Simple ions are just the atom which has either lost or gained. So whatever I have written on this board are all simple ions. कुछ simple ions के नाम देखो, जैसे इस साइड में नाम होंगे क्या क्या? सोडियम, पोटेशियम, लिथियम. Sir, get me some from those sides. Okay, N3 minus, S2 minus, O2 minus, Cl minus, Br minus. These are all simple ions. This is what I have written. Whatever I have explained is all simple ion. Dhruv darling, do I need to remind? Oh, what is really bad today? Your face, your look, internet connection. Fractions? Oh, connection. No, you just log out from the neighbor's internet connection and log on your connection. Sir, when I download one PS4 game, sir, connection is very fast. Sir, Instagram connection is fast. ऐसा कैसे रे, सारा पेबल सिटी में तेरा ही कनेक्शन खराब है, तो घर पे है कि बाहर है? घर पे तेरा ही कनेक्शन कैसे खराब होता है? किसको गोली दे रहा है? पापा घर से वर्क फ्रॉम होम करते हैं ये, और उसमें ऑफिस में माइक्रोसॉफ्ट टीम्स वीम्स कॉल होता है। आज के जमाने में खराब कनेक्शन मतलब जानते हो? द फर्स्ट वन टू येल एट माई हाउस विल बी माई मदर। टेलीविजन इज नॉट वर्किंग, राइट? सीसी कैमरा नॉट वर्किंग, इंस्टाग्राम नॉट वर्किंग, एवरीथिंग इज नॉट कनेक्टेड। तो बंद करना चाहता है वो डायरेक्ट बोलना, को ये सब सब बैड कनेक्शन, as if he is locked down from that small modems we used to have ना एयरटेल। ठीक है, समझ में आया प्रिंसिपल? सिंपल मॉडर्न। अच्छा, इन सिंपल बेटा, इन सिंपल, नाउ देयर इज अ वे, द बुक विल टेल यू, देयर इज अ वे आई विल टेल यू। इफ यू फाइंड दैट these ions are coming alone without anyone, let's say I form a compound where I have got, say, potassium's K plus and nitrogen is what? N3 minus. This bonding is not possible right now because the net charge is still not zero. I have to make it zero. Do you understand? Try to understand. Pay attention here. I want to make something from potassium and something from nitrogen. Potassium says, take away electrons. Nitrogen says, give me electrons. So there is a very nice donor and a very nice acceptor. The only problem we are having here is that the match is not matching, right? So it says 3 potassiums come together. Can I now write this as K3 plus servos, 3K plus and N3 minus? We don't write K3 plus. Now is it matching? Matching, right? Now how do we name this compound? If you look at it, this is nothing but an ionic compound. Ionic compounds are very easy to name. The way to name them is that the positive ion or the metal part is always spelled first. Positive part of the metal part is always spelled first. So who is the positive part out here, beta? Potassium. And it is just the name. Straight away take the name of the parent atom, potassium. समझ में आया? उसके साथ कौन आया? Nitrogen has come. Now nitrogen has come alone. Maybe in count of 1 or count of 2, that does not matter. Has nitrogen come with any other carbon, oxygen or anything? No. As long as nitrogen, the element, comes alone, the name always will end with IDE, ide. Ide. So this name will be nitride. Do you understand? So if you spot this ion, what do you call its name as? Just see. Somebody shows you, where is it gone? This one. Somebody shows you this. If they say, write the name of this ion, what will we write? Potassium. Positive ions are always the name of the parent. Potassium ion. Look at me. Lithium ion, sodium ion, potassium ion बोलना जरूरी है. Ion बोलिएगा. Beryllium ion, magnesium ion. Magnesium, no, this is not atom. Calcium ion, boron ion, aluminum ion. Fine. Did you understand how I named them? Simple. Let's start naming from here. Nitride, oxide, fluoride, phosphide, sulfide, bromide, chloride, iodide. You write down, and if you have any doubt, you can ask me again. If the ion is coming alone, the ion's name in case of anion will always be IDE. Kirtan, once again, see, nitride, oxide, fluoride, FLUORID, fluoride is fluorine, not fluorine. Pronunciation is very important. She stands on the floor holding a bunch of flowers and makes cakes out of flour. So pronunciation is very important. Phosphide, sulfide, bromide, chloride, iodide. उच्चारण स्पष्ट कीजिएगा. Our Hindi sir used to tell us, the way you pronounce depends upon how much of air you are breathing and how much you are holding and how much. Fluorine, Yes, Nidhi, pronounce the word fluorine. Let's see. Yeah, there should be fun classes also. Till that time. Yeah. How do you? Fluorine, fluorine. There should be that E should be heard. Fluorine, fluorine. Yeah, urine, like that. Fluorine, that's it. Fluorine. That U has to come. What do you fill in your car? Fuel? Fuel. 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 Yeah. Not fuel. Not fuel. Fuel. Yes. Fluorine. Fluorine. What is maida? The one which you use for making cake? How is it pronounced? Yeah, I'm asking you only, Nidhi. Oh, maida? Yeah, maida. The one we use for making cake. How do you pronounce it? Just how you pronounce it? No, not the Hindi name, ma'am. The English name. Oh, wait. I forgot. Wait. Hey. No. You don't know the name of the commodity called FLOUR? No. And what do you get as a bouquet of? A bouquet of? Flower. Aim for flower. That's so Indian. Flowers. That's flower. Flower and flower. So you do not elongate one, you do not elongate the other. Flower. Flower means give me a bunch of flowers. Flower. And what you're standing on? Floor. Okay, chalo. Koi baat nahi. Actually, which floor? I stood on the floor and I made a cake out of floor. Hear me now? ठीक है, समझ में आया? Simple and compound. ठीक है, compound नहीं पढ़ाया, अभी आपको सिर्फ simple पढ़ाया. So in the case of simple, the names will always be. So look at some common examples. CO2, carbon dioxide. HCl, hydrogen chloride. H2O, okay, there is a problem. H2O should be dihydrogen oxide, but there are some compounds which take name from the way they were discovered. They are an exception. H2O is known as water. CH4, carbon tetrahydride it should be, but it is known as methane. NH3, nitrogen trihydride, but we call it as ammonia. He remembers ammonia very nicely. Okay, good. That's how you should from that test. Chalo. Now let's see the polyatomic and the compound ions. This is something interesting. One day I had given you a list. I don't know whether you hold it or not. Polyatomic. And in your book, the word used is compound ions. Now simply, compound ions can also be, they can also be cation and they can also be anion. But the only difference is, in the case of simple ion, beta, you only had one atom becoming an ion. Here we will have, in both the cases, we will have group of atoms, obviously different, and can be repeated also, which are covalent bonded. But since you are an ion, afterwards you will always have some net charge. And this can be positive or negative. Positive है तो आपका नाम होगा compound cation, or in our case we call it polyatomic cation. And if it is negative, it will be compound anion. देखो बच्चा समझ में आया कि नहीं? Try and understand. Compound ions can also be cation and anion. Here we will have group of atoms, different, and there can be repetition of an atom also. These atoms will be actually bonded in covalent bonding, and there will be a net charge. That bonding we don't study here. That bonding will be studied in higher classes. They have just given some structures in your book that is as good as not understanding about it. Okay? They don't understand, make you understand. So let's take some examples. Here there will be a plethora of example for anions, and all these anions are actually coming from respective acids. Though the book does not say, we will understand it that way. The first one you should know is sulfate. SO4 2 minus comes basically from sulfuric acid, H2SO4. Now start thinking. Hydrogen is in family 1, though we don't count. SO4 is 2 minus. So somebody, now here you will understand oxidation state. Let's find out what is the oxidation state of hydrogen in this particular molecule. The oxidation state, look children, now you'll ask me, sir, what is the difference between valency and oxidation state? Valency never changes. Oxidation state changes in compound to compound, molecule to molecule, depending upon with whom and how you are bonded. So if you look at the oxidation state, what is the valency of hydrogen? We will always say valency of hydrogen is 1. Does hydrogen want to lose an electron? No. Always gain an electron. Okay. Sulfate, I said, is SO4 2 minus. So if you want to find out the oxidation state of hydrogen out here, I say oxidation state of hydrogen is X. I don't know. 2 times of X plus SO4 is 2 minus 2. And since this is a stable compound, it should be 0. So what is the value of X? You yourself see, 2 and minus 2 cancel with 1. X is equal to plus 1. So hydrogen is standing with an oxidation state of plus 1. How many hydrogens, sir? 2 hydrogens. So plus 1 plus 2. They balance out this minus 2 and compound is stable. How many of you understood? How many want me to repeat it again? Repeat it again? Okay. Are you clear with valency? Valency will never change. Oxidation state changes from molecule to molecule depending upon how the neutral charge has been achieved. Now SO4 is one type of a polyatomic anion. It carries a charge of minus 2. Now SO4 we know comes from H2SO4, sulfuric acid. Is sulfuric acid stable? Yes, stable. ये molecule तो exist होता है दुनिया में. That means what should be the net charge on it? 0. I don't know what is the oxidation state of hydrogen. So how do I find out the oxidation state of hydrogen? I assume it to be X. Got it? I have got 2 hydrogens, so 2 into X plus this is minus 2 should be equal to 0. So if you want to do your calculation, you do it this way: 2x equal to 2 or x is equal to plus 1. So hydrogen is standing with plus 1 oxidation state out here. Is it clear? Let's see one more example. This will become clear. Oxidation state. Copper oxide in this world is found in 2 ways. One is CuO and one is Cu2O. कॉपर के 2 ऑक्साइड्स होते हैं बेटा, CuO and Cu2O. ठीक है ना? अब देखते हैं कौन सा कैसा है. What is the oxidation state for oxygen? You straight away know. Oxide as an ion carries minus 2. Hey Nidhi, why didn't you answer this? Oxygen as an ion, not oxygen as an ion. Oxide ion carries minus 2. We just saw that. 8 minus group number, 8 minus 6. Okay, so this is minus 2, this is minus 2. Let's just for the first one, assume this is X. X minus 2 is equal to 0. So X should be plus 2. Means here the oxidation state of copper is plus 2. समझ में आया बच्चा? Again here, let us assume X. Then in this case we say 2 into X plus minus 2 is equal to 0. X equal to plus 1. Here the oxidation state is plus 1. The same copper shows multiple oxidation state. And later when you see this, did you remember in the middle part of the periodic table I was silent. I said they are transition elements. So when you go to grade 11, you will learn transition elements show multiple valencies. They have variable valencies. And copper is a transition element. So it shows plus 1 and plus 2. Right? Now, which is higher? Algebraically, plus 2 is higher. The higher, and there will be a lower. The higher one in terms of Latin will always end with ic, and this will be us. So the lower one will be known as cuprous oxide. Higher one will be known as cupric oxide. But IUPAC says, shut up. You can't do all these nonsense. But still we love to say it in this manner. IUPAC says, just write copper because The metal part we always name the atom, है ना? Sahasra, metal part. And with copper, who has come? Only oxygen. So it should end with oxide. Copper, what? Oxide. But in this case, we will write copper 1 oxide. In this case, we'll write copper 2 oxide. But if you want to love chemistry, I would say आप ये भी याद रखो, cuprous, cupric, एक हमेशा higher वाला होता है. Like in the case of iron, you will see iron's oxidation states are +2 and +3. So the +2 compounds of iron will be called ferrous. The +3 ones will be called ferric. But IUPAC says, shut up. Iron 2, iron 3. Your book will always write it like this, copper 1, copper 2. But if you love chemistry, you should know this way also. Okay, so where were we? We were on compound ions. So compound ions will have, like, this was just to make you understand oxidation number. So SO4 is 1, then comes CO3 2 minus. Okay, this one is known as sulfate. Sulfate, carbonate. Then comes NO3 minus, nitrate. Sir, how are you understanding it should be 2 minus or 1 minus? For that, either go to grade 11 and understand these bondings, which is not in our scope. We are not in 11. We don't know how this bonding is happening. We just know that they are covalent bonded. So you have to have some extra love for chemistry. What is the extra love? You should know the acids that they make. H2SO4, this acid is H2CO3. Again, CO3's marriage is with hydrogen. Hydrogen is +1 always. And 2 of them. So how much? CO3 is 2 minus. Look at nitric acid, HNO3, only 1 hydrogen. Therefore, this will take +1, this will take -1. Okay, let's take one more, although the book does not have. PO4. PO4 is 3 minus, known as phosphate. So, sir, what is the acid? H3PO4, phosphoric acid. So, if you again want to learn chemistry, बेटा साइड में लिखते जाओ, ये एसिड्स को लिखते जाओ. Sulfuric acid, carbonic acid. Carbonic acid is the acid which you find in the can of Coca-Cola. You drink that. Carbonic acid, sulfuric acid, carbonic acid, nitric acid, phosphoric acid. So what are the 4 polyatomic anions you learned from this? Sulfate, carbonate, phosphate, nitrate. ठीक है, लिख लीजिए उनको. All your book shows like this. See, the book will show like this: 1 carbon bonded with 3 oxygen, and then they will put something like this and 2 minus. But they don't show how the bonding is happening. That we'll learn in grade 11. So rule समझ में आ गया? How to name the rules? With this particular polyatomic or what we say compound anions, depending if an element is combining in 2 different ways with 2 different oxidation number, then we say polyatomic or simple. Then you have to write in bracket the oxidation state. That's the example that I tried to show you. With the same oxide, copper combines in 2 different ways. ठीक है? अच्छा. When you come to metallic side, cations, there are very rare example. In fact, there is one non-metallic cation which is actually positive, NH4 plus. This ion is known as ammonium ion. Ammonium ion. ये लिख के रख लो. This is the only non-metal cation. Only non-metal cation. Rest of them, just look at all the anions that I have shown. All the anions are non-metallic. This is, everything is non-metallic out here, but it is a cation. Ammonia gained 1 more hydrogen. Very easy to understand. Sahasra. What is ammonia? NH3. You gained 1 more hydrogen. You became NH4. Hydrogen, what does it have on its head? Plus ion. Ammonium. And now you can yourself think of a compound, and the compound is something like this. Try to name this compound, beta. NH4Cl. You know the simple ion of Cl? What is the simple ion of Cl named as? Chloride. No, not chlorine, chloride. Chlorine is the name of the atom. We did with her so much. Fluorine, fluorine, chloride, chloride. And this is what? The cation. What is the name of the cation? Ammonium. The cation does not change its name. So what will the name of this compound be? Ammonium. Ammonium chloride. Ammonium chloride. And speak it loudly. You will be wrong. You're learning. That's the way we learn. Ammonium chloride. Rather, you should always, the thing which you make wrong, you'll never forget in life. I never forget the name of tin. Tin is SN. I was made to stand for that. A teacher kept on asking everyone what is oxygen, phosphorus, and she came to me and asked what is tin. I said TN. How do I know? Tin is SN. वो कभी नहीं बोलते हैं, गलत बोला ना, ठीक है? NH4. अच्छा, can you name me this compound? NH4, NO3. Let's first see whether it will be 1 or 2 or something. ये जो आपका दिमाग में 1, 2 लेके बैठा रहता है ना. NH4 comes with what type of a bindi? Plus bindi. NO3 comes with a negative bindi. How many negative? 1 negative, 1 positive. Super pairing. You don't need any adjustments out here. Did you understand, Kirtan? What will be the name of this compound? Why nitrite? यार ये आँख के सामने लिखा है फिर भी गलत बोलता है. Ammonium nitrate. Okay, can you make ammonium sulfate? Try and think. How to make ammonium sulfate? Sulfate means SO4 will come. SO4 is always 2 minus. कौन आ रहा है इसके साथ? Ammonium आ रहा है. Ammonium is what? 1 plus. So when we write the name of the molecule, it's like this. What will be the name? Don't write diammonium nitrate. It's ammonium sulfate. Ammonium sulfate. Can you make ammonium chloride? Just upfront. NH4F. NH4F. Ammonium chloride. Okay. So I think we have done with this. Next we will go for formulae of covalent compounds. We'll go as per the book only. So that we will do in next class. नहीं तो आप एक दिन में ना बैठ एक दिन में आपका ज्यादा हो जाएगा. Then we'll do formulae of covalent compounds and formulae of ionic. Ionic is the one that crisscross arrow one. You all know about all this, so we'll go fast. Major part of the thing that I had to teach, I have taught. Now we can increase our speed, but provided, although you see your class notes, please watch this video and come in the next class. And read up till this much portion. I have just made you done till formulae of covalent compounds. We have not touched that. Right, children? So we'll catch up in our next class. Yes, sir.